You've been there, right? You try to feed an AI a long document, a full code base, or even just a long conversation, and it just chokes. It slows way down, it starts forgetting things, and it absolutely devours your GPU memory. The advice is always the same, just buy bigger, more expensive hardware. Well, Google just dropped something that completely flips that logic on its head.
And it all comes down to a problem that honestly most AI content just glosses right over. It's this hidden bottleneck that's been slowing everything down every single time you hit enter on a long prompt. And until right now, nobody had a really clean solution for it. Okay, let's get into it.
So the culprit? It has a name. It's called the key value cache, or the KV cache for short. It's this part of the AI's memory that often gets overlooked, but it is the real reason your AI struggles so much with long inputs.
See, when a large language model processes your prompt, it doesn't just read the words and move on. It stores a running memory of every single little piece of information, every token. And for every token at every single layer of the model, it creates two data points, a key and a value. So as your conversation gets longer, that cache just balloons. We're talking exponential growth, and this is what gobbles up all of your graphics card's precious VRAM. Now, you've probably heard of fixes like 8-bit or 4-bit weight quantization. And don't get me wrong, they're great for shrinking the model's weights down so you can actually load it into memory. But here's the thing almost everyone misses. That does absolutely nothing for the KV cache. The cache is still running at full precision, getting bigger and bigger with every token you add. It's like putting your car on a diet, but leaving a growing pile of bricks in the trunk.
And this is where Google's new paper, TurboQuant, comes in. It's this super clever two-stage compression algorithm that is designed specifically for the KV cache. It doesn't touch the model's weights. It goes right after this memory bottleneck.
So how does it work? Well, it's pretty brilliant, and it happens in two main steps. First, picture your data as this scattered cloud of points in space. A process called polar quant basically just rotates this entire cloud so that all the points line up more neatly on a grid. Once they're lined up, it's easy to round each point to its nearest grid line, which takes way less data to store. We're going from 16 or even 32 bits down to just 3 or 4. Then, the second step very cleverly handles the tiny error that's left over from that rounding. It uses a bit of math to store just the direction of the error. Was it positive or negative? Which, it turns out, is just enough to perfectly preserve all the important information.
And the result of all this is kind of mind-blowing. The AI's performance, its attention scores, they come out exactly the same as if nothing was ever compressed in the first place. And the best part? No retraining, no fine-tuning. You can just plug this into models like Llama, Mistral, or Gemini, and it just works right out of the box.
Okay, so the theory sounds amazing, right? But what about the actual results? Well, this is where it gets crazy. The numbers from Google's own tests are just jaw-dropping.
First up, memory. TurboQuant uses 6 times less KVL memory than the standard full precision method. That's not a small tweak, that is a massive leap.
Then there's speed. On a high-end NVIDIA H100 GPU, it ran the core attention computations up to 8 times faster. And get this, that speed up gets even bigger as the context length grows.
And here's the real kicker. All of these incredible gains in memory and speed came with literally zero loss in accuracy. Perfect scores across a whole range of tests. It's basically the holy grail. Smaller, faster, and just as smart.
And this chart just says it all, doesn't it? Look at that memory reduction. You can see just how dramatically smaller that footprint becomes. This completely transforms the economics of running these models.
And look, this isn't just Google marking their own homework. Independent developers have already ported this to local libraries, and they're confirming the claims. One test on a big 35 billion parameter model got a 100% exact match up to 64,000 tokens, while cutting that KV memory by about 5 times. So yeah, the results are real.
So let's make this crystal clear, because it's maybe the most important takeaway. Methods you've heard of, like GPTQ or QLoRA, they compress the model weights. That helps you load a big model. TurboQuant solves a totally different problem. It compresses the KV cache. That helps you actually run the model on long imports. And while weight quantization can sometimes slow things down, TurboQuant actually speeds them up. Ideally, you'd use both together for the ultimate performance boost.
All right, let's zoom out for a second, because this isn't just a cool new algorithm. This kind of breakthrough could signal a much bigger shift in the entire AI industry.
Now check out this timing. It's pretty wild.
On the exact same day that Google published the TurboQuant paper, OpenAI announced they were shutting down their video generation app Sora. The very next day, Disney reportedly pulled a $1 billion partnership deal that was tied to it. It really suggests that the cost and inefficiency of running these massive models is starting to cause a real change in strategy.
And why does this matter? Because what we're seeing is the entire industry starting to pivot. It seems we're moving away from the era of bigger is better, this arms race to build the largest possible model, and into a new race for smarter efficiency. It's not just about who builds the biggest AI anymore, it's about who can get the most intelligence out of the infrastructure we already have. So let's bring it back home. What does a breakthrough like this actually mean for you, whether you're just running models at home or you're a massive enterprise?
Well, once this gets integrated into mainstream tools, your local setup, even on consumer hardware like a Mac Mini, could comfortably handle massive 100,000 token conversations. For businesses, VentureBeat reported this could slash cloud inference costs by 50% or even more. I mean, this is a shift so big that memory chip stocks actually dipped right after the announcement.
Now, I do want to add one important caveat here. As TechCrunch pointed out, this is still a lab breakthrough. It's not yet widely deployed across every piece of hardware and every framework out there. So maybe don't go canceling your GPU orders just yet, but definitely keep an eye on this one.
You know, at the end of the day, TurboQuant is exactly the kind of thing that doesn't get the same hype as a flashy new chatbot. It's math, it's infrastructure, it's the unsexy plumbing work that actually makes everything else possible. And this is what separates temporary hype from real, lasting progress in the field.
Which leaves us with a really big question for the future. It seems pretty clear that the companies that win in AI won't just be the ones with the biggest models, but the ones that can squeeze the most intelligence out of every single byte. So, is this it? Is this the start of a new kind of AI arms race? One focused not on size, but on smarter efficiency? Let me know what you think.